lesson 2 variables and input and output, Python 201. So variables are a place that we store a value. We give it a name or a label, and then we can call that label to get the value that's held inside of it. When we give a variable a value, it's called a variable assignment. So in this example, the variable name is country, and the value assigned to it, that's what the equals means, assigned, is America. Once a value is stored in a variable, it can then be accessed anywhere in the program by using that variable's name. So for example, if we had a variable named X and we gave it the value 1, 2, 3, 4, 5, 6, 7, and told it to print X, it would print 1, 2, 3, 4, 5, 6, 7. If we gave it a value of hello and told it to print X, it would print the word hello. So there's a couple different ways to think about variables. I like to think about them the exact way they do that in here. It's a container for information. The value on the right side of the equal sign gets stored into the named container on the left side. So for example, car is the container, or the name of the container, and Toyota is the value that's stored in it. Or in my case, it would be car and it would be Hyundai. When you use the variable's name, it is replaced by the value stored in it. So when I say print car, it actually gives me the value that is stored inside of that container. So another way to think about a label is all of these. So a variable is a label drawer that stores one piece of information at a time. It is like a name tag that is put on a value, and it is also like an envelope that stores just a single value. Those are all acceptable ways to think about variables. It wants you to practice this, and it says store your age as an integer in a variable named age. So I typed age and assigned it the value 40. That's how you read this statement right here. And if I click play, it'll tell me I did a good job. The next one says this instruction assigns the value welcome to Tinker using the variable greeting. So if I click play, it says welcome to Tinker because it said greeting equals Tinker. So if I print greeting, it's going to print whatever value is inside of that greeting. So I could say, oh, well, let me change them, so never mind, we can't do anything with it. All right, I already did all of this. So naming variables are some very specific syntax, specific things that you need to know with variables. They can only contain letters, numbers, and underscores. This is Python specific. Other programming languages have different syntax rules that go with variables, but this is what we have. So the variable greeting is acceptable because it is just letters. The variable the weather today with underscores between the words is also acceptable because it uses underscores and letters. Now we're going to go through and fix the syntax errors in these. So it says a variable cannot have spaces. This variable is awesome space sauce. That's not acceptable because it has a space in it. There's a couple different ways that you can go about this. The way they're trying to get you to do it is when there's a space to use an underscore, which is not my favorite thing to do, but we'll go with what it is that they're asking for. So an underscore, and if I click play, now that one works. If I play this one, it says the variable name cannot start with a number. It's Three Musketeers. Three Musketeers is not valid. They can't ever start with a number. So one way to fix this would be just to do Three Musketeers. And then it would work. And then a variable name cannot have punctuation or special characters. No, if I play this right now, no dashes you can't have a dash in there. That's a special character. Only underscores. And then no punctuation. This one has 2 exclamation points. You can't have those in there. So no dash, you could just get rid of the dash. Punctuation, get rid of the punctuation. And that would fix those 2. So finally, it wants us to fix these variable names. So replace, they're telling you specifically how they want you to fix it, which is annoying because this is not how I would name these variables, but we're going to go with what they're asking for, or it won't let us move on. So replace spaces with underscores, remove any dashes or punctuation, and remove numbers at the beginning of variable names. So this one, replace this space with an underscore. In the second one, it wants us to remove any dashes or punctuation, which I think is silly. You should just replace that with an underscore if you're going to go with that, but whatever. Get rid of that exclamation point. That can't be there. And then 101 Dalmatians cannot have the numbers 101 in front of it. That is not acceptable. Variables allow you to access the same value in multiple instructions, making it easier to change the information your program uses. So in this example, there is a song. It has a first line, chorus, and then a second line, and then it's repeating those lines over and over again. If I click play, you can see it's going to grab the values that are inside each of those variables and print them in the order that it's telling you to. It's asking you to change that if you want. It says alter the value of the variables to change the song. I'm going to change I don't know what I'm going to change it to. Let me think. So I decided to pick this song right here. It's just going to repeat it over and over again because I'm not adding more lines in. But whatever. Oh, I spelled baloney right. Yeah, no. Baloney. It has a G in it, I swear. But I guess not. Baloney. There we go. Now it's fixed. Yay. When a variable is reassigned to a new value, the old value is gone forever. There's no way to get it back. It's replaced with a new one instead. So once it's changed, that's it. It's gone. This is change the values in the variables, names, and actions to alter the output. It says print your first name. And this says then print your friend's name. Now the old values that were in there are completely gone forever. Each time I change these, they're going to be gone. So if I change, the first time I printed it, it was Sarah. Now the value is Stacy. If I give it new ones, the value is going to change again. Okay, so let's look at this little problem here. What are the final values in the variables A and B? A equals 10, B equals 15. B equals A, so then B is going to be 10. And then A is going to be B, so 10. They're both going to be 10. So the old value of B is first replaced by the value stored in A, which is 10. Then A is assigned the value that is stored in B, which at this point is also 10. When two numbers are added with the plus sign, the computer will evaluate their sum or add them together. When strings are added together, that's called concatenation. The letters are joined into a single string. So if we look at this example right here, print 1 plus 2. So that's the the integer 1 plus the integer 1. That gives you the value of 2. If I print the literal strings, hello plus goodbye, it combines those two strings into one chunk. A computer evaluates addition with strings the same way as addition with numbers. So let's play this one and take a peek. 1 plus 2 plus 3 are the integers being added together. This line says 1 plus 2 plus 3, and it will add them in that same order, but smoosh them together, which is called concatenation again. You can join variables with literal strings to add labels or additional characters around the variable's values. So this says friend equals Sarah. Print, my best friend is space plus whatever value is in friend. So this should, by looking at it, say my best friend is space Sarah. Yes. And if I wanted to add a period to the end of that, I would say plus period in quotation marks, and now there's a period at the end of that sentence. If you remove the space right here, is and Sarah will be combined right together. That space right there gives the space that goes between these words. You can join multiple variables with strings to produce more complex output. So this is change the values of the variables below to your own city, state, and country. So I live in Madison, Wisconsin. And if I click play now, it says, I live in Madison in the state of Wisconsin, United States. Yours might say DeForest. I live in DeForest in the state of Wisconsin, USA. Or maybe Windsor. Or maybe you live in, I'm trying to think of all the little bitties all around that area. Morrisonville. Oh, what's that other one? The name of it always makes me hungry because it sounds like sausage, bologna or something. I can't think of the name of that place. Print a sentence. It says combine the subject, place, and activity variables to print sentences in the format the subject goes to the place to activity. Subject scientist, place lab, activity research. Expected output. The scientist goes to the lab to do research, not to research. Oof. All right. Ooh, print. Let's build this. The space plus subject plus space goes to the space plus the actual value inside of the variable place plus 2, put spaces around it, plus an activity. I could spell. Let's play that and see if it worked. Yay! Hooray! The input function asks the user for a value and returns the result. The value that is returned by the function call can be stored in a variable or used in another calculation. Run the code, type in your name, then press the Enter key. So, I said name, and then input, enter your name, requested for me to type my name in. So I could have typed whatever I wanted in there. So let's say, if I click play again, if I said SpongeBob, it would say SpongeBob because it's going to print that out. The argument to the input function is the prompt that's shown to the user. So input, it says enter your name. This is what shows up. It prints this out and expects you to give value back. This one says run the program below, then walk through the animation to see the process that a computer uses to evaluate it. So play. It says first name, Sarah. Last name, Shagam. And then it adds my last name to my first name. I should have put a space in there. Can I change it? Nope. Why use inputs? The input function makes it easier for a user to interact with your program. Instead of defining the variable age as a particular value, age equals 12, and expecting users to manually change the value, the input function allows the program to adapt to each person that runs the program without changing the code. It says try this. Run the program multiple times with different ages to see how the output changes. So I'm going to click play. It says enter your age. I'm going to enter 40. It says you're 40 years old. Boo. Play. 15. You are 15 years old. 105. You are 105 years old. Let's try this interactive story. The interactive story allows a user to fill in certain blanks with words and phrases of their choosing. The storyteller has to think about how to structure a story without making it specific to any one character or item. In your story, you should use the input function to get values for each of your variables. Oh, it's going to be like a MadLib. Yes. Answer equals input and then question. Then have another user run your program and input values for each variable. See if you can use their feedback to improve their story. Ooh, yes. So, we're going to do this and turn this in. All right, so I built a little MadLib kind of thing here. It says friend, and I'm doing your input, your friend's name, food, input, favorite food, activity, input, verb, or an activity ending in ing, otherwise the sentence gets all weird. Place, input a place, and then it says print friend, and I love to eat food when we go, whatever, at, wherever. So if I hit play, it's going to ask me, so I'm going to say friend's name, I'll do Stacy again, favorite food, pizza, verb, swimming, and a place would be at the mall. Stacy and I love to eat pizza when we go swimming at, oh, you can see that if I add the to it that it'll be better. So let's try that. Stacy, pizza, swimming, mall. Stacy and I love to eat pizza when we go swimming at the mall. That doesn't make any sense, but that's the point of MadLibs. It'd be more fun to do this and then share it with somebody else and have them do it. So I think maybe we will share these together in class. So you're going to want to hold on to this code. I think we'll probably do this together in a new Python screen. All right, multiple assignments. You can assign multiple values to multiple variables, or you can assign values to multiple variables in the same line using commas to separate them. So for example, in this one, it says x, comma, y equals 10, comma, 15. X will get the value 10, so it lines up first and first, and then y will get the value 15. So if I play this, 10, 15. You can assign to any number of variables as long as the number of variables and the values is the same. If you had 3 variables and only 2 values, it wouldn't let you do that. It has to be the exact same amount. So this one is ABC 1, 2, 3, and you can see it adds them together. Swap 2 values. The multiple assignment instruction can be used to swap the values into variables. In this example, A is equal to apple and B is equal to banana. A comma B equals B comma A. It's going to swap the values. A is going to now be equal to B and B is going to be equal to A. Am I talking gibberish? Print A, and the value of A, print B and the value of B. They should be opposite. B should be equal to apple, A should be equal to banana. Look at that. Look at what they're doing. They're just switching the values in this assignment. I don't know why you would ever do that, but they're showing you that you can. Sum both ways. Given two strings A and B, set the value in A to A plus B and the value in B to B plus A using only one assignment instruction. Then print the value in A followed by the value in B. Whew, Nelly. Here we go. Given two strings A and B, set the value in A equal to A plus B. And the value in B, oh, only one assignment instruction. Oh, good gracious. A, B equals, this could be A, B, A. Let's see. No, just this. A, B. So first we're going to set A equal to A plus B, and then B equal to B plus A. And then it wants us to print A, and then print B. And I'm not going to do the quiz with you.